Hey YouTube, this is Brendan with Cusack Prep, and in this video I'm going to be showing you the derivation of average velocity and average acceleration for AP Physics C. Now, what I have presented here is from calculus, and if you're early in the year in AP Physics C, you may or may not be familiar with this. But this equation helps you figure out the average for any function. It's proven. And so we're just going to kind of accept it as a fact for now. We're going to show how we can use it to figure out the average velocity and the average acceleration. So let's say we wanted to figure out the average velocity. So the average velocity, we're going to call that V average. So we're going to take this here and we're going to write V average. And if we're looking at some average velocity, we're looking over some interval of time. And so this B and this A, these are going to represent the bounds, where I'm going to let A be the initial time, and B is going to be the final time. So A, and that's not acceleration, but that's that A, is going to be my initial time, and B is going to be my final time. So B and A represent the interval over which we're evaluating the velocity. So then instead of 1 over B minus A, this is going to be 1 over T final minus T initial. All right. And then we're going to go ahead and we're going to evaluate this integral. And T1 is going to be T initial, and this is going to be T final of f of x. Well, since we're trying to figure out the average velocity, f of x is going to be our velocity, and our velocity is a function with respect to time, and then dx is just going to be dt. Well, if you remember or recall, we understand that the integral of velocity is what gives us our position. So if I integrate velocity, which is a function of time, and I integrate it with respect to time, that's just going to give me my position as a function of time. So this whole integral here, I'll do this separately. If we integrate from the initial time to the final time of v of t dt, well, that integral is just going to equal x of t. So that integral equals x of t. But we have to evaluate that from the initial time to the final time. So what does that mean? Well, that means that's our displacement at the final time. We plug in the top value for t, and then we subtract our displacement at the initial time. Well, if I take essentially my final value of x, and I subtract my initial value of x, we can just go ahead and rewrite this as delta x, or the change in position. So this whole integral here, as I've shown, that whole part of it just turns into the change in position. And 1 over t final minus t initial, well, that's going to be 1 over delta t. And if I have 1 over delta t times delta x, well, that's just delta x over delta t. And that proves that our average velocity over some interval, t initial to t final, can be written as delta x over delta t. Now, in a completely analogous manner, we can do pretty much the exact same thing and show how average acceleration can be written. So I'm going to go ahead and do that down here. So our average acceleration, I'm going to write as a of average, is going to equal 1 over t final minus t initial times the integral of the average, or the acceleration as a function of time from t initial to t final. So let's go ahead and see what this looks like. Now, we recall that the integral of acceleration with respect to time is just velocity. So this right here, just like last time, I'm going to go ahead and do this off to the side. But the integral of t initial, or from t initial to d final, of a sub t dt is just going to equal v sub t, which is then evaluated from the initial time to the final time. And plugging in t final, we would have v of t final minus v of t initial. And the change in velocity at the end versus the beginning, this just ends up giving us delta v. So once again, this whole integral has just turned into delta v. Now at the same time, 1 over t final minus t initial, well, that's just delta t. So this becomes 1 over delta t. And this whole integral became delta v. So we can see from this that our average acceleration is just equal to our change in velocity over our change in time. And that's how we can use integral calculus to prove these two equations for average acceleration as well as average velocity. Thank you for watching. Hope you found this helpful.